Right. Okay. Wait a second. Right. It should be working. Hello, everyone. I'm Stokarz, and today we're gonna be telling you a little bit about the experiment we are doing and the practical thing. Okay. We are working on in our studio, which is basically trying to solve the problem of how do you distribute the cryptocurrency to your users, players, whatever. Anybody that's using the app. It can be a bot, it can be an AI. And we are exploring the technological branch which we call activity-based cryptocurrency distribution, taking all the lessons from basically two protocols that did it well. So Bitcoin and of course Ethereum with their proof of work and proof of stake. I think these are like the perfect examples how you should be doing cryptocurrency distribution, either inside infrastructure or applications. And I'm gonna tell you a little bit more of what we've been working on and what's actually is starting to work. So I'm Stokarz, I'm a founder of Minters. And we are a small studio creating on-chain games. So the problem is quite simple. How do you distribute the tokens? To whom? Based on what rules? What kind of the activity? And the most important one is, what does the world itself gain from it? Okay, so this is a very important thing, because we need to look at this thing not from the perspective of what the user gains, but what the world itself gains. And this is very important. Okay, so is the protocol incentivizing the right set of behaviors? And you look at the world and think, what's the most valuable thing for the world itself? And depending on the kind of on-chain game you are creating, it can basically be, well, maybe the most valuable kind of activity is basically burning the gas, so keeping the world alive. But it can be many different things, and I'm going to show you in a few seconds. The other question that needs to be solved with this implementation is basically, how do you protect the world itself? How do you protect your fully on-chain game from spamming, inflation, all this stuff that came with, for example, the growth of Axie Infinity? Right, so let's design the protocol that's able to reward a programmable behavior inside any kind of on-chain simulation. So either if you're running a DAO, if you're running a DeFi protocol, whatever, we want to find a solution for basically doing one simple thing, programming the kinds of behavior that you think is valuable for the on-chain world itself. So how do you do that? First, well, you need to decide what's valuable. Then you program it into the protocol. And next, the protocol itself rewards the users before performing those tasks. So there are like 3 goals. And we came to this after basically our own experiments in the studio. The first goal is that distribution goes to actors performing a valuable activity inside on-chain worlds, on-chain games. So this is the first goal we need to aim for. The second one is activity itself assures that the world is alive, that there are people doing something inside this world. If not, well, you're gonna end up with a dying game or a dying world. So we don't want to do that. The third goal is, of course, protocol automatically adjust when activity is increasing or decreasing. And this part is the most important factor that we came up with, because you could see, like, before these improvements, most of the games in crypto were basically doing the first part, the first goal, the second one, but then they were all failing because there weren't anything that has been adjusting those activities. And you can think about, like, even traditional economics inside our physical world. If somebody starts mining gold with pickaxe, he's being rewarded with a gold, right? But if a lot of people, like thousands of people, start mining gold with the pickaxes, the rewards the work needed to actually get the same amount of gold is going to be much higher. So the physical world is naturally adjusting to those things, to increased activity. But we haven't seen that actually in crypto. The best example, of course, is the Bitcoin itself, where you have the when you have block mining difficulty, and it adjusts in time. So if there's more hash power inside the network, the difficulty adjusts, but the reward stays the same or decreases if the halving mechanism is of course applied. If you want to go with first, like if you are distributing a token for rewarding any kind of behavior, maybe you want to have the high inflation at the beginning. Like let's say you assume that the world for at the beginning, it will be valuable for the world to have like 20% of the inflation in the beginning, but then you say, okay, but after that time, I assume, there's a lot of assumptions, but you assume that it will also be valuable right now to have the reward decreasing. And we can take a lot of lessons from, for example, like biology or even training LLMs and apply those lessons into crypto. So what we have practically achieved, we've built a game that's called Rascal. It's a fully on-chain game. And we've also implemented a very simple ranking system to it, where we take all the specified actions that we want the users to perform. It can be like, it's a pod racing game. It can be like killing the enemy sheep. So you know that somebody is actually playing and implementing some kind of the strategy, so he's winning. Or it can be something like just winning a game. So you know that the user participated in some kind of like the match, for example, did a lot of activity, and then finally won against some other agents. But the moment we are in is basically the first part is fully on-chain, and that's amazing, but we haven't yet solved out the part where the protocol itself does the distribution in specified epochs. Right now we are doing this part as like experimental 3 months session, and we are doing the second part off-chain. So the next goal is actually having all of this on-chain, and then I think we're gonna achieve what I'm talking about today. So this is how the ranking system looks like. For now, users perform specified actions that we actually specified, and then they get basically they are assigned the scoring for these on-chain actions, and they can see themselves in the global ranking board. And after that, we take all this scoring and sees like whoever performed the most valuable activity for the network itself is rewarded with the tokens. So this is how you basically incentivize the activity inside the world. And of course, right now we are running it in the 3 months epoch, but we already know that you could basically do it on the weekly basis. And it should be, if the part of the distribution would be on-chain, it would be adjusting basically the same like you could see with Bitcoin's mining difficulty. And to give you one more very practical example, so again, you decide what kind of behavior you want to see inside the world, and then users perform those actions, and you reward them with the tokens. And you can think of a very simple idea about that's potentially very close to what we are going to be doing in autonomous worlds. Let's say you are running inside like a huge procedurally generated world, okay? And then let's say you need to pick up steel. Why do you need to pick up steel? Well, because there are a lot of islands, and people want to explore the islands because there are a lot of resources on the islands, right? But you can't go on the horse through islands. You need to build bridges. Okay, it's working perfectly. You need to build actual bridges between the islands. Okay, so let's say we know this is the issue. And like with the work in our real life, let's assume that it's going to be beneficial for the whole world, okay, from the perspective of the world itself, to have players basically putting a lot of resources, a lot of work, and creating bridges between those islands. And that's as simple as that. And then if that happens, we can actually, from the protocol perspective, reward the users that did just that. So the user gets the very simple reward. And now one of the other interesting facts is what happens if basically everybody starts building bridges between islands? Because, well, somebody sees, okay, this is profitable because he got the rewards at the beginning. Maybe I can also do that. And then you're gonna see like a lot of people automating this thing with basically on-chain bots. So how do you protect? As a world, it's still very, very positive for you that somebody is actually connecting all these procedurally generated islands, because then other players can come and easily create economic activity between those islands, because assuming, of course, there are resources on those islands, or you need to go through them to some other locations. So we don't want to punish this behavior, but the protocol itself needs to adjust the rewards to basically not run into a lot of inflation problems. So if the number of bridges between islands in some specified epoch increases drastically, the protocol needs to automatically adjust to this. And yeah, with our work, I think we are really close to actually achieving that technically. The last challenge we've been actually thinking is crazily interesting. So how do you basically generalize what's valuable activity for any kind of on-chain protocol, any kind of on-chain world? And this is a huge question, actually, because you can see, like, the biggest example I gave at the beginning was, I think the token distribution, the currency distribution was done really perfectly inside Bitcoin protocol and inside Ethereum protocol. But they were doing the same. They were basically specifying very, very limited amount of activity that needs to be incentivized over the, of course, consensus. So the challenge for anybody that's building autonomous worlds is basically asking, how do you generalize this? And we don't know currently. Actually, we have some ideas, but we don't know. And why should you generalize that? Well, our best guess is, as with natural world, you're gonna have a lot of emerging behaviors on top of just, mining gold with a pickaxe or building the bridges between islands. Maybe it's gonna be like somebody build the bridges, but then you should then you will see some emergent behavior on top of just building bridges. Maybe you will see like racing cars going through those bridges, and it's gonna be very valuable because there will be a lot of people coming in and potentially, I would say, like betting on those races. And let's say this drives the activity of the world itself like 10x. So you can actually see this activity is very valuable for the world itself from the world's perspective. So, and you don't want to change that. If you program something, it needs to be permissionless. So you itself, as the admin of this world, you want to have it immutable. You don't want to change anything. So the protocol itself needs to be generalized. And this is our first naive guess was to basically check whichever activity spends the most amount of gas, because as you know, like very simple activities that are being computed over the any kind of blockchain are actually like not really expensive in gas. But then as you run up the complexity, and you can think naturally, okay, doing jewelry is potentially more complicated, more complex than just using the pickaxe to mine the gold. So this kind of activity should actually cost a lot of more gas on the chain. So our naive solution to that would be actually to measure gas that is being spent inside the autonomous world, and whichever activity spends the most gas, you assign the scoring according to that and reward this activity. But then we already know this is a potentially wrong solution, but we don't have any better idea. And this is a wrong solution because you could potentially run into the situation where basically something like automating the agent that is running over like two-dimensional plane, that is your world, and just running around in circles, gonna be the most gas-spending activity. And well, you don't want to really reward that kind of activity. So this is a like huge question still to be solved for, and I hope we're gonna achieve that in a few months. So yeah, that's gonna be it. Thank you very much.